All right, shaky camera time. I'm here in the garage now. I just have an old power supply plugged in here. You know, when I was hooking these leads up, again, you don't even have to worry about damaging this thing, because if you plug the leads in the wrong way, there's a protection diode on the input. It's right here, this one N4004. And so I just kind of plugged it in until it came on. So it does just come on, so I'll show you that. And I mentioned earlier that you should be able to drop this down to about maybe 6 volts before it peters out. Let me get these both in frame. Again, sorry about the shaky video. I just don't have a clean thing going on right now. So this thing is going. I'm going to just drop the voltage on. You can see we're pulling, yeah, 110 milliamps, which is basically right on with what they say. They specify 120, and so yeah, 113, sure. Probably this instrument's not even 100% accurate. It's close enough though. I pulled this out of the trash, so. So let's just turn the voltage down. You'll notice because they're using an LDO here that you're not going to use any less current as you change the voltage really until it starts to peter out. But look, we're already at 8 volts here, which is the minimum they recommend. I'm guessing we can go back down to 6. Now, I don't trust the voltage output on that thing, so I'm going to get a DMM real quick here. Again, I'm doing all these videos just kind of on the fly, so if you're not technical and geeky, this second video, well, the first video probably wasn't for you either. The second one definitely is not going to be for you, because I'm just going to be playing around with this thing here. What I'm doing right now is I'm just hooking up a fluke DMM, because I don't care about the current per se, but I do care about the voltage. I just don't want to hold leads, so I'm using little banana connectors instead of the clip-on leads, assuming I can find more of them. I'm going to make a mess. I should have prepared for this, but let's see, do I not have any more? There's one lead. I have a whole bunch of Anderson connectors here, so I take all my cables that are low bandwidth and I just cut them in half, and then I put these Anderson connectors on there because you can plug any Anderson connector of the same series into any other one. Hey, there's one more in there. So I used to have a rack where I'd hang them all up, but I don't do that anymore. So let me plug these in real quick, and then I'll stop moving around as much as I am now. I just need to get a more accurate voltage meter going here. So there's that. Okay, so look, there's our voltage now. You can see, you know what, we're not too bad. 7.25 versus 7.3. We're going to switch over to the fluke. You can see there's some, come on. You can see there is some aliasing on this screen. Now, that's not due to the voltage. This is simply due to the ADC itself. So we're going to keep going down again. I think we can probably hit down to about 6 volts. You can actually see, look, we're falling out of regulation. So that's why they're saying 8 volts. Now, why is that? If we were monitoring the 5 volt rail, we'd see. So you can definitely see here that there is some. Okay, all right. Respectfully, their 5 volt rail is dropping down. And then we can come up here. You can actually see though that above 8 volts our LDO works. There's 9 volts, 10 volts. Sorry, you can't see it. 11 volts. Okay, cool. So I mentioned earlier changing the LDO U5. So there's U5 there, the 7805. So I basically took here's a TO220 version of it. There's the screen, sorry. If you were to put this TO220 version and then kind of just fold it down in there, you could run this thing. Let's look up the 7805. Let's see. There's the screen there. So 7805. And yeah, there's a blah blah. So I want to pull it up from Fairchild, sure. I hate using these online websites because I hate to give them the clicks. Alright, I should have just gone to DigiKey. I know where everything is in DigiKey. Drawing details, maybe that's it. That's not going to be a PDF. Oh my god, alright, fuck it, we're going to DigiKey. DigiKey, where I only use it because I've used it forever. Sorry, only one hand.com. Okay, and we're going to look for 7805. Don't care who makes it. But it does need to be a voltage regulator. Yeah, there we go. Let's pull up a data sheet, and I want a TO220, so let's find the package here. It's going to be through hole, and it's going to be a TO220. Yep. So there's one there, and they're all pretty much the same. We'll pick STs. So this guy, you can see, well, they don't even, this company doesn't even offer the other guy. So this will do up to 1.5 amps. We're using 0.1 amps, 5 volts. So let's find the absolute maximum input voltage. Yeah, blah, blah, blah. Again, I don't recommend this thing, but it's there. We'll just keep using it. There, guys, it's such an old circuit. So this will take up to 35 volts for a 5 volt thing. This is absolute max. You don't want to run it at 35 volts. But you could definitely put 12. You could run this off your car, for example. Okay, so the last thing we need to do is we need to look up the delta thermal resistance values. So we're looking for they got a lot. Oh, because it's for each regulator, right? Okay. So where's your temperature? It's probably going to be at the very end. Typically for the mechanical engineers, you guys go down to the bottom to get your... Oh, okay, all right. Goodness, there is a lot of information on this part, which is crazy. So we're looking for the theta JC. There's thermal pads, we're close. There's some dimensions, more dimensions. Okay. My God. Okay, this data sheet is kind of insanely. I need to know how much power you can take without overheating. It's a lot. But is that going to be it? No, they want a cap. Is it? Degree? No. Okay, well, we can do the math. This thing will do 1.5 amps with a small overhead voltage. Fuck me, where is this package information? TO220. It's on page 40. Which I'm so confused. Where are the page numbers? Okay, let's find another company's. I don't like. Let's find Onsumi's. That page is just blowing my mind up. Hey, look at this. I like Onsumi stuff. Okay. Okay, excess of 1 amp, no external components. They do want you to use a cap. Okay, here we go. Look, right on the first page. The 220 case, which is 221AB, is 65 degrees C per watt. So this chip, that's to ambient with no... so if you just stick this guy on the board, which is what we're going to do, and we put 1 watt through it, it will be 65 degrees hotter. So how does this LDO work? Well, if we put 12 volts across it, and it's got 5 volts on the output, we're going to have 7 volts dropped across it, and we're pulling 120 milliamps max, 840 milliwatts. So we're going to multiply 840 milliwatts times 65 degrees, and it's going to be 55 degrees warmer C. And yeah, that's totally fine. Look, the operating is up to 150 degrees C, which is very hot. Now you don't want to run it that hot. You might run it at 190. But anyway, in a standard, gosh, even if you're running this at 40 degrees C, you're running, that's pretty hot. For the Fahrenheit folk, that is 100 degrees. So you can run this thing up to 105 degrees very easily. And then let's see, 45, say even 50 times 9 over 5 plus 32. You could run this at 122 ambient and you'd still be totally fine. So really sticking that TO220 on there, the 7805 220 case, you're gonna be able to use this thing at 30 volts if you want. 20, not 30. That's totally a lie. What did I say? 12 volts, right? What did we say? 12 volts, yeah. So which is already what they have. So say you're putting this in the car, which might be up to 16 volts. That's good. That's really what I'm looking at. So 16 minus 5 is the voltage drop across, And then we have up to 120 milliamps, so that's 1.32 watts times 65 degrees C. So now we're looking at 85. So now if we add our ambient in a car of 40, that's gonna be 125 degrees C across that case, worst case. So, you know, whatever. I think that's still fine. And if it does break, you can just put another one on there, or you could put a heatsink on it. Because look, the junction to case, which is the actual mechanical, 5 degrees C per watt. So if you throw a heatsink on there, man, you can run that super hard. So you could maybe throw a little small little finned heatsink on there, and you'd be good to go. Anyway, yeah, you can run this thing up to 30 volts probably with a big enough heatsink, and certainly in a car, 16 volts, big heatsink, no problem. So let's come back over to this thing. We're at 10 volts here. Now, you know, I was looking at the cable again. It's super neat, but it's going to be really hard to measure stuff with. So I'm going to just use a different probe, but I'm going to set that probe to the 1x range, because this thing is not set up for a 10x probe. I think you'd have some really interesting interactions because of the way their analog front end works. All right, so I just have whatever probe. Now I've taken all my things out of here, so I can't switch them out of 10x. Unfuzzy, there you go. So I'm gonna have to just use a little screwdriver to put them back. Gosh, you guys, if you haven't gotten sick yet watching this video, I'm sure you will, because I'm willfully unprepared for it. Okay, so we're in the 1x range now. I just flip my probe over using the NI screwdriver, which, man, I love the NI screwdriver. All right. So we're gonna plug this guy in here, like so. And let's get ourselves a test signal. I'm not gonna use the test signal in there because it doesn't have the header. I'm just gonna hook up to another oscilloscope, get its test signal, and that way it can also, this is the 1054Z. This is my favorite scope, hands down, for the dollar. You know, a lot of companies will buy each one of their engineers, you know, $30,000-$40,000 Tektronix scope. This is $400, and for the most part, I think with the, say you have 10 people on your team, you can get 9 1054s, do 99% of your work, and then if you do need actual like accuracy or more bandwidth or whatever, you can use your one expensive unit. Okay, so I've got a test signal plugged in there, and it's not seeing shit. Interesting. Let's make sure the test signal, I mean, I'm sure it's there, but maybe it's not. So there's our test signal. Yep. Right. As you'd expect. This probe's actually not compensated correctly, nor am I triggering off the, oh, I'm triggering both ways. Okay, there we go. So there's our signal. One. Yep, that's basically what you'd expect. Yeah, you can see the probe's not compensated. I'm not going to worry about that right now. Over here, we're not seeing anything, probably because, look, we're ground coupled, so that's going to be the first. Now, before we come out of ground coupling, let's make sure we're in the right range. It's going to seem like that's going to be the 50 volt range, so we want to go down to 5 volts like that. So we're in the 1 volt per division, presumably, and then we're going to DC couple. So there it is, working. Our trigger's not in the right spot. Nor are we really in the, let's see, this is saying 1 volt per div. So this is saying that it's a 3 volt signal. Is it a 3 volt signal? I thought it was a 5 volt signal. Oh, it's 3 volts, so look at that, perfect. Not lying, I thought the gain was wrong. Okay, let's get this trigger working out. Again, I've never used this before, so let's see, trigger, that's the trigger thing. There's going to be a select. Oh, okay, you push the button and it moves around. I can get on board with that. So we got the select button. Don't know what we've selected. Okay. So I think we're selecting things I don't know, and then okay, something came on the screen. So yeah, there's, you know what? Okay, don't know. Push a button. What are we doing? Okay, there's your trigger. I guess that selected the trigger. Yeah. Okay. Okay. Yeah. Okay. So the first click goes here. You can see the blue auto, whether we're triggering on the high or the low end. We'll stay on the high end here. And then next up is the actual trigger level. That was hard to see because it just turned blue over screen. And then here's going to be the range, maybe. Don't have a clue what I'm doing now. Ah, okay. So this guy turned blue here. And so we're now moving based on where that trigger occurred. Now it doesn't tell you where the trigger occurred, I don't think. It's probably just centered. And then you push it one more time and you're going to get your range. So you can move your range guy. Now let's see if this does... Okay, well I can't change... I was thinking, oh, I'll just change the range here, but again, this is when you actually flip the buttons, it'll tell you which range you're in. So I'm railing there, of course, 0.1, there's the 1, and that's because of the divider on there. This will be 20 volts. 2 volts, sorry. And 5 volts. Again, because we don't have the 10-to-1 probe. Man, I'm not even going to do any more testing. This does exactly what I need it to do, which is to monitor signals simply. I do want to, the one thing I want to do, I want to see if the 500-second range is actually there. And so what we can do, I'm going to hook up to the actual power supply instead. So, how am I going to do this? Okay, well, we'll actually just go. So I have a BNC probe that has Andersons on it here. So we'll plug this guy in, get rid of our other probe. Okay. And plug in our BNC connector. And now instead of plugging into this DMM, I'm going to plug it into here. So I need to make sure I set the right range here. We're going to go to well, you know, we could be in the right range. Yeah, we'll just leave this in the 1 volt range. Okay, it's showing JYE tech again. I'm not sure why that just showed up. I'm going to plug this in real quick to the power supply, and then we can just modulate the power supply. And see what that is going to do. Okay. Oh, I did also want to check. Okay, so we are way over range now. Let's go to point. Okay, 2 volt range. So this is saying 2, 4, 6, 8, 10, which is about right. But let's go on the time base, which was just what I wanted to do, and scoot that time base way out. See if we actually can go to 500 seconds. Okay, well already we can see it doesn't actually update, so it's not. It doesn't do a line style plot. That's fine. So if we go to, it does here though, look at that. Okay, so maybe it is doing a line. If I vary the voltage, okay, well, that's interesting. It's not, oh wow, there is some major delay to that. Check that out. Okay, I have the DMM disconnected. So I am changing the voltage on the power supply. You'll see what I'm going to do. I'm going to go down to, I'll go up to 12, which is its maximum rating. And then I'm going to drop down to 8, which is the min. And then I'm going to go back up to 12. You can see there's a ton of latency. It's probably, you know, I'm probably just off screen. Yeah, I'm probably just off screen because there was an option to move around there. This makes sense because it can only display a few lines at a time. So I think what it means is I need to throw, okay, plus actually goes to the negative end. Okay, that's weird. So minus is going to make you more positive, and that's just a frame of reference. So, goodness, this is slow. The scroll is very slow. So definitely, like, that's my biggest complaint so far, is that if you want to look at this real-time data, it takes you 10 seconds to just go over there. Okay, so now if I adjust the voltage, so there's 8 to 12. That's respectable. Yeah, okay, I'll give you that. That's fair. So not an actual latency issue. Okay, so now when I go up to, okay, we're gonna hit set some more. Kind of weird only having this one button. You gotta just toggle through. Okay, 2 seconds also toggles. Okay, so it is continuously strip charting, which I like. So you could set this thing, look at that, 500 volts, 500 seconds does exist. So you could set this thing here and then come back and look at it, you know, hours later and see, now this is only gonna work for DC signals, but that's sweet. You wanna monitor the charge on a battery or something, like, or not the charge, you wanna monitor the voltage across the battery over time? That's pretty neat. So you could do that while you drive and have a continuous thing. Now you're only able to store 2,000 data points, but not bad. Okay, so let's go back over. I want to play around with the triggering. I had a theory earlier that the triggering was going to be noisy because of the PWM output. So, yep, you can see, look, my voltage dropped down there, so that's cool. 20 bucks! 20 bucks and you get this shaky ass video. I usually spend a lot more time on the video production quality, but not on this one, sorry. It's cool, but we'll see. Okay, so I'm just hooking this thing back up to the oscilloscope, where I'm sure it's going to alias like crazy now because we've hooked up this signal. I think we hooked up the signal. Yeah, there it is. And it's not seeing anything. So that's interesting. Check it out. There's some aliasing going on here. So we have this signal going, and just because of the way the ADC is sampling, sometimes it's high and sometimes it's low. If we slow this thing way down, there's our actual unaliased data. And let's drop the range. Maybe we can get away with that. No. Okay, that's fine. So yeah, here we are. We got all the triggering. We got the little trigger LED flashing. It's flashing a lot faster than you can see on this screen here. It's probably flashing at about 1 kilohertz, if I had to guess. I don't know what the OK button does. Oh, it holds. Okay, so the OK button here is a hold. That's nice. I like that. Single, no matter what you're doing. Okay, and then what I wanted to come over here is look at the different modes. We have normal, so that if the signal stops, signal is stopping. Yep. Oh, we have a hold, so I took the lead off. There's our signal again. Okay, and then we should have a single as well. Let's see how that works. Okay, so how does single work? I'm going to disconnect my signal, and then I guess I have to hit OK, and it's running and it's waiting. So I'm going to hook my signal up, and I should get one thing and a hold. That's exactly how I'd expect it to work. Okay, what else do we have? Okay, so it doesn't roll, it doesn't wrap back around, so that's kind of confusing. Maybe single and then normal, auto. So, cool. And then we have to start. So it's neat that we have this stop button always. I really, really like the stop button there. That's pretty cool. Okay, so the last option here is the trigger level, and again, it doesn't wrap around. Minor complaint, like it doesn't wrap around, but we have high and low side triggering. We don't have a both trigger, but that's fine. And gosh, wow, 20 bucks! That's crazy. That's absolutely crazy. Good job. I'm gonna 3D print this thing, a case, and we'll be good to go. Wow, amazing, absolutely amazing.